In this particular use case, we are going to integrate AWS Lambda with S3 and DynamoDB. As a step 2, we will create an endpoint in API Gateway, which will trigger this Lambda function. And then we will consume this endpoint in the Jupyter-based node. A quick overview of all the services that we are leveraging in the context of this particular use case. AWS Lambda is a serverless application, which means that you can run the code without provisioning or managing servers. You only pay for the compute time you consume. An AWS Lambda can be written in any language, be it be Python, be it be Node.js, or be it be Go. So there are different languages that are supported by Lambda, which you can leverage. There is Simple Storage Service, or S3, AWS S3, which is nothing but a secure, durable, scalable object storage infrastructure with unlimited capacity provided by AWS. And then there's DynamoDB. The DynamoDB is your NoSQL database. It's a key value document database that delivers single-digit millisecond performance at any scale. And it is entirely managed by AWS. And then finally, there's the API Gateway. The API Gateway is the route through which we are going to provision an endpoint which will trigger the Lambda. Again, API Gateway is a fully managed service which developers can use to create, publish, maintain, monitor, and secure APIs at any scale. So in brief, let's go over the details of the application that we are looking to develop. We have a host of machine learning challenges which the data scientists are working on. The data scientists have the blind data set with them. Whereas in our application, we have the actual results. Now, the data scientists, once they build the model, they're going to apply the model on the blind data set, and they would need a method to validate the model. So they are going to call the API that we are going to develop, and then by calling the API, they will be able to validate the results of that particular model. So in short, the API that we are going to build is going to give them a certain feedback in terms of what are the metrics related to the model that has been evaluated. So having set the context, now let's jump right into it. I've already signed up for the AWS free tier. There are a lot of free tier services available within AWS. I have also created multi-factor authentication. I have set the password policy. I've created an alternate user to carry out my experiments. And just a caution, as per the AWS recommendation, the root user should never be used. So you always use the alternate user who you assign as an admin privilege or the least privilege, depending on the task that you're looking to do. So let's jump right into the AWS Management Console. I've already logged in, and this is my Management Console. And let me go to the Lambda. So as you can see, I have multiple couple of functions which I've already written, which is nothing but compute model score and fitness score. We'll look at compute model score. So let's click on create function. And as you can see here, I can give any specific function name that I'm going to call. And then I can specify a runtime. So as you can see, the following languages are being supported, whether it's C#, Go, Java, Node.js, Python, Ruby, and a few more. So you might want to have a look at it. For our experiment, we are going to look at Python 3.8. And then I'm just going to click on create function. That is the first thing that I need to do for creating the function within the Lambda. So as you can see here, I've already created the compute model score new function within the Lambda. And this is the boilerplate code. The boilerplate code gives you the main function, which is nothing but the Lambda handler. And whatever functionality that we are going to code will be between the return statement and the to-do implement. And if there are some functions that you are going to call, they have to be declared before the actual Lambda handler so that they get compiled first. So by default, Python library doesn't support a lot of additional libraries like NumPy. It's not supported by default. You need to add them as a layer. So the way we do it is you click on layers and then you can say add a layer. And then when you click on add a layer, you are able to select from a list of runtime compatible layers. And you click here and you will be able to see that there's something called a SkyPy and a NumPy. So this is a library which can be added on top of what we have already created. So I'm going to add it and then I'm going to say version 4 and then I'm going to say add. And as you can see, once I did that, this particular layer is added on top of my Lambda function. Now what it essentially means is that now I can code anything by using the NumPy library. And as you can see here, I have added the layers and then you can see the layer that I've also added. So by default, the Python function within the Lambda does not support pandas. And pandas is a very popular library for handling data. It is not supported out of the box. However, there are workarounds through which you can upload the pandas as a folder onto the AWS layers and then have it supported. So there is a workaround for getting support in terms of usage of pandas. However, for the current functionality, we are not going to use pandas, hence we are not going to use it. So we also need S3 storage service. So we want to access S3 storage service on the services menu. And then as you can see, I've already created a bucket for me. Okay, the app factory ML experiments S3 bucket. A couple of things to know that when you create a bucket, it has to be a unique name across AWS. So it has to be like cognizant.com or IBM.com. So the idea is it has to be a unique name across AWS. So I've already created a bucket, and you could create multiple buckets. Okay? I have already created a bucket, and I've created multiple folders within that bucket. Now, one of the key folders that I have created is something called the test data files. Now, test data files has got two different files here, which is called the housingprice.csv and titanic.csv. Now, these files are essentially the actual results to the blind data set that I was mentioning earlier. Now, from an application perspective, we are going to read this particular data, and then we are going to compare that data against the submitted data which the user has done to the API. So now that we have looked at S3, so we'll go to the DynamoDB. Now, DynamoDB is fairly simple in terms of table creation. Okay, you can just click on create table, and then you can give a table name, and you also have to give something called a partition key, which has to be a unique key. And you can either give string, binary, or number, and this has to be fed through the code. So in this case, what I've already done is I have created a table called, if you look at the tables, I've created multiple tables now for different reasons. So I've got something called ML challenge result submission. Now when I click on it, I should be able to see all the items, correct? And this is it's a key value path. As you can see here, this is one of the sample records that I've created, correct, through the Jupyter Notebook. So when I click on this particular record, I should be able to see all the data points that I'm storing it, correct? So there's a challenge name, there's a challenge type, there's an F1 score, there's the date and time during which it was entered. There's a partition key, and remember the partition key has to be a unique key. So, and then the user ID, correct? And then you can look at all metrics. So remember, there's a key value path. So there's a JSON data. So you within the all metrics, you'll be able to see all the relevant metrics that are part of the evaluation mechanism. So as you can see, From a classification model perspective, I've got all the metrics from a confusion matrix as well as the precision and recall. So this is the DynamoDB, and that is the S3 storage that we saw earlier. Now, what we are going to do is we are going to go back to Lambda. Okay, and then I'm going to click on compute model score, which I've already coded, and then I'm going to show you the different pertinent aspects of the library that you need for you to interact with both S3 and DynamoDB. Let's have a quick look at the important libraries within Python, which will help us to interact with the AWS services. So one of the core libraries is Boto3. So using Boto3, you can create an S3 resource, and then as you can see here, I can identify a specific bucket within the S3 resource, and I can give that particular name, and then that bucket will be automatically assigned. Similarly, if I want to interact with the table that I've already created, which is the ML challenge result submission, I can use the Boto3 library and identify DynamoDB as a resource that I'm going to interact with, and within that resource, which table I'm going to interact with. So as you can see, I have created 3 different variables: S3, bucket, and Dynamo. A couple of things. I'm going to assume that I'm going to send challenge name as part of a parameter, and then a couple of other parameters as well. So if you remember, the objective was to read the actual results and then compare it with the results submitted by the data scientist. Now I already know where the file is located, and since I'm parameterizing the challenge name, I can refer to the challenge name.csv. So in case I'm going to send Titanic, it is going to retrieve the data from that bucket within that folder, and it is going to retrieve Titanic.csv, and then it is going to read the contents of that particular object. Remember, S3 is all about object storage. It's not typical file storage. It's an object storage. So once you read the object, you need to process the object. Okay. So in this particular context, I'm going to do decode of UTF-8, and then I'm going to use the split lines function to get all the data elements. Then I'm going to use something called csv.reader. I'm going to read the contents of that particular data. Now, as you can see, the first statement that I have written here is header is equal to the next of lines, which means it will read the first line, which is nothing but the header that I have submitted. I'm going to ignore the header, and then I'm going to process only the data which is after the header. Now, if you remember, we had created a variable called Dynamo. So let me quickly go to that particular slide. And if you see here, I've already created a reference, a pointer to the DynamoDB table that I would like to insert my records in. So the way I do it is simply by saying dynamo.putItem, and then I'll give the respective JSON object, which is the item here. And I'm going to give the different data points, like the challenge name, the challenge type, which user ID, F1 score, and you can also see something called all metrics. And if you remember, I showed you the screen on the DynamoDB, which had all metrics as yet another JSON object. So metrics data is nothing but a collection of all the metrics related to the evaluation of that particular results. So if you just say dynamo.putItem, then the entire data point goes and resides in DynamoDB. As simple as that. So I'm going to spare you with all the coding details, which I have already referenced in my GitHub for the lambda sample.py. So please go and have a look at it, which will give you the entire function. So now let's go back to the AWS Management Console. So one of the important things that I have not mentioned so far is called the API gateway. If you remember, the objective of creating this lambda function was to somehow invoke that function. So there are multiple ways we could invoke that particular function. Now, but my requirement is I would like the data scientist to invoke this function from that Jupyter notebook. Now, if you look at the PyTest sample which I have created, now in this case, what I have done is I'm doing something called a post event. So I'm collecting all the data relevant to the submission, the challenge name, the user ID, the challenge type, and the submissions data. And then I know the URL, correct, where I'm going to hit in terms of which URL that I'm going to hit, and also the function that I'm going to hit. And then I'm just going to use the request object and do the post along with the JSON data that I've constructed. Now, what it is going to do is it is going to activate the Lambda function. It is going to process the data that the data scientist has submitted, and then it is going to return the results. Now, as you can see here, I've just printed out all the IDs, right? And then what, if you look at it, the actual returns, right? If you just give me a spare a second, the actual returns will look like this, which will give you in terms of, hey, what was the challenge, what was the, this is something which we already sent. It will give you metrics in terms of how much is true positive, how much is false positive, how much is false negative, so on and so forth. It also gives you like accuracy, F1 score, and all the metrics related to that particular evaluation. Now, this is only for classification. Now, if you were submitting the results for regression and you pass a linear regression, correct? And then it will go and give the results related to the regression. Now, let's go back to the API gateway. So the way you add a trigger is just say add trigger, and then you can select API gateway as the option for you to interact with the Lambda. And then once you create the API gateway, remember you should, when you create the API gateway, you should have an open connection and not a connection with JWT, which is JSON Web Tokens. For at this point in time, we want to have an open connection. So just to give you a perspective, let me just quickly click on trigger and let's say API gateway, and then it will ask you, and then it will say, okay, create an API, and then it's going to say, okay, I want to use HTTP API for the current scheme of things. And then what I'm going to do is I'm going to say security, is it going to be a JWT authorizer or open? So for our purposes, I'm just going to say open, and then I'm going to say add. So once I do add, it is going to create the API gateway for me. So once it creates the API gateway, I should be able to see the URL, correct, in terms of where I'm going to post the data. So you guys, you can see it shows a particular endpoint which you are going to plug it in your particular notebook that the data scientist is going to evaluate. And these are parameters that we are going to pass, like, hey, what is the challenge name? Remember, only if you give the challenge name will it be able to go and retrieve that particular file for comparison. So challenge name is very critical. And then it also says what type of challenge that you want to do. Like, is it a binary classification or a regression? Now, these could be stored in the DynamoDB itself. And then when you make a request based on the challenge name, it could know the challenge type, but I choose not to do it. I just choose to send binary classification as an approach using the post data. A little more information about API gateway. There are two methods to which you can interact. One is the get method and one is the post method. In the get method, you would need to pass the parameters as part of the query string, which in this case I choose not to do. So what I do is I return an error message like get not supported. As you can see, if I find the HTTP method is get, then I say the get not supported. And in the case of post method, so you are able to pass the entire data point as a JSON object. So get is useful in the context of, say, if you're building a calculator and you're sending two numbers, then get becomes a convenient way to pass a query string parameters. But if you're passing a large body of data, then I would recommend you go for a post. And as you can see, I am able to read once I load the the body parameter, which using the JSON.load, so I'm able to reference the parameters that I already referenced in my code, which is the challenge name, the challenge type, and the submissions data. So we are almost close to the completion of this particular session. I would like to leave you with a few important pointers. One is loosely coupled services, the other is elasticity, and finally the serverless based service. Now, the loosely coupled services is an important design pattern in the context of cloud computing. So imagine you are developing a web app and you have several services as part of this web app. Let's say in the context of this, the machine learning challenges, you have a service which is for evaluation, you have a service for updating data, you have a service for data scientists joining the challenge, and so on and so forth. Each of these could be developed as an individual unit, correct? And kind of reduce the dependency between these services so that it becomes very loosely coupled, so that a change in one will not affect the other. And that is the greatest advantage of having a loosely coupled services. A special mention to serverless based service in the context of AWS Lambda. As you can see, AWS Lambda supports multiple languages. So if you are developing a web app on, say, Node.js, right, and let's say I'm good in Node.js development, I might choose to do the entire web app on Node.js, but I would like to use services, right, something which is mathematical. Probably I would like to use Python as a framework for implementing the mathematical functions, because I know there are extensive libraries to support that particular activity. So I kind of create these loosely based services on Lambda, and so I am able to do in multiple platforms. So and choose the best of the breed, correct? So choose Python where it is applicable, choose Node.js where it is applicable, and then it becomes a very powerful design. The biggest advantage of serverless based service is the elasticity. So you do not have to pre-provision any of the servers or computings. So in this particular context, with whatever I have developed for evaluation of model, I can serve one user, I can serve 100 users, I can serve 1,000 users, I can serve 10,000 users, and so on and so forth, without having to worry about how it will be served, correct? So AWS takes care in terms of provisioning that services. So hence it's called a serverless based service, and hence it's very elastic, correct? Elasticity is one of the important design components of cloud computing. So you're able to serve one user on one end, and the same function is able to serve 10 million users. So, and that's a big jump, correct? So if you have to provision an infrastructure for serving 10,000 users, and let's say our traffic is anywhere between say 1,000 to 10,000, which means that I have to pre-provision my infrastructure for 10,000 users, which might not be feasible. So having an elastic kind of a service, which means the function is able to accommodate itself, accommodate in different scenarios, either be it 100 users or even be 10,000 users, it is able to work seamlessly. And that is the biggest advantage of using a serverless based service. So, and on top of that, we also use DynamoDB, and DynamoDB again is a completely managed service from AWS. So, it gives you a read performance about single digit milliseconds, correct? So in this particular context, though we didn't use it for reading, we used it for write purposes. So before an important thing before we complete this session that you might want to consider is the permissions. So what we need to do is a role has been created for you called the compute model score. You need to give this role the permission to interact with DynamoDB. Now, if you don't give the permission to interact with DynamoDB, most likely you are going to have an error. So the way you do it is you click on the compute model score role, and then it will take you to the IAM page where you are able to attach different policies. Now, as you can see, I have attached a policy called Amazon DB full access. Now, you could give some kind of a very customized policy as well. So as you can see, I have S3 read-only access, which I have given, In addition to that, I have a DynamoDB full access. So in this particular context, if you want your Lambda to only write to DynamoDB and not read, you could give a customized permission saying that, hey, I only want to write to DynamoDB. So this is very critical. So unless you give this particular permission, your Lambda will not be able to interact with the DynamoDB service. A quick information about CloudWatch, and if you go and look at services and search for CloudWatch, you'll be able to see that CloudWatch is nothing but an application or a service within the AWS which helps you to monitor resources and applications. You can click on it, and then so once it loads, you can go to log groups, and you will see that a tag has been created for you, which is called the compute model score in this particular case. And when I click on it, all the requests that you see has been logged, correct? And then you can click on any particular request and you can analyze the log. So in case you have some print statement, in this particular case, I had a print statement which prints all the metrics that are being returned as part of the Lambda function. So you could see that particular log, and it's a good way to address what issue that you're facing. Say, for example, you didn't give the right permissions to interact with DynamoDB and it fails, then this is the place where you will get that particular error, and you might be able to solve that particular issue. One more thing that Lambda provides is, again, a quick overview. We go to compute model score, and as you can see here, there's something called select a test event, and then so you don't have to really interact with the API. Let's say using a Jupyter notebook, and you just want to do it. You want to test your use case, correct? Locally, and this is the way this can be done. So I have created something called post request event and post request event regression. And if you go and look at it, the configure test events. So what I have done is I have passed the respective parameters like the resource, path, HTTP method, body, and so on and so forth. Then I'm able to click on test and be able to test that particular function that I have written. So this is a local way of executing this particular Lambda function, and be able to test it for different use cases. So as well, so you could also attach an API gateway, and you could look at how to invoke that API gateway from any of the services. So a final thought, when you look at AWS free tier, and let's look at all the services that we have consumed so far. And as you can see, there are different types of free tier: 12 months free, always free, and trials. And let's look at Lambda. And if you see Lambda, interestingly, let's just Lambda. Sorry. So you have one. So if you look at it in terms of the free tier, so you have about 1 million free requests per month and about 3.2 million seconds of compute time, which is a huge amount of thing. Right? And then let's look at S3, which we were using. You get about 5 GB of standard storage. So there are different tiers within the S3. Right? You might want to do a quick read up on S3 if you are not familiar. So there are different tiers within the S3. The standard tier, you have 5 GB of storage, and you can get about 20,000 get requests and 2,000 put requests. So let's say we look at DynamoDB, and DynamoDB is one more service which is available. You get 25 GB of storage, which is free, correct? And then you have about 25 provisioned write capacity and read capacity units. So I believe we are in good hands in terms of the free tier. Let's look at API gateway. And API gateway, again, interestingly, correct? So you get about 1 million API calls received per month. Even the incremental cost is very minimalistic. So if you are doing some kind of sandbox testing or building some kind of a application and you want to test on Amazon, please feel free to do it, because we have a good amount of free tier. But I would suggest you put the necessary controls in the necessary controls in the CloudWatch, so that you are able to monitor your billing as well as usage. Right? final thoughts. Hopefully you like this particular session. I had a real fun interacting with AWS Lambda and integrating the Lambda with DynamoDB and S3 and API Gateway. It was a fun experiment. So it's very, in these tough times, I think the best way to beat the blues is to program something and see something happening. And that's the best way to beat the blues. Take care and be safe.